Hi, I'm Rob Farkas. I'm from Premier Construction Consulting. I'm here today to do a little exploratory surgery on the ceiling that's behind me. It's got water damage. We have a couple running theories, but that's the point of this. We're here to actually figure out where the source of the water is and then come up with a plan to fix it.
Now, before I actually start cutting, I wanted to show some of the existing damage that we have and do a little commentary. This is an area where Dean and I poked around on Monday, today being Thursday. The drywall that came down was damp, and that's a little suspicious because one of the original theories is that the mister system has a leak, and this being February, it would have been quite some time since the misters were actually operated last, unless there's been some recent maintenance done and they ran the misters. But that drywall was damp when it came down, and this is actually an area that I'm going to cut because it's completely broken away and soft in this area, so it's pretty obvious that some water's been pooling there. And I'm going to walk over along the radius portion of the house, and we've got another area where right there you can see in the center of the screen is sagged, and that's actually an area that's given away as well, and it's dropped. And I have one more area past the pillar here right there. So these look like two areas that the water has chosen to run to those locations and then release itself from that point. I want to come right to the outside and look up at this deck. I call attention to that efflorescence that's on the face of the stucco. Efflorescence happens when water goes through a concrete product, and the water carries the lime out of the concrete product and brings it to the face. And in Arizona it comes to the face because the relative humidity outside is less than maybe water that's trapped in that wall, so it actually wicks through the concrete. Okay, and now I'm going to get to the cut portion. Okay, I've got the first section down, and on the leading edge, that dark gray right there is an indicator of mold, which would be pretty common with a damp area. But also there's the drywall that came down, and it certainly didn't come down in one piece, and it is very wet. And there's mold on the back side of that drywall as well. Okay, now we're up underneath the walk deck, and that, as my camera's having a hard time focusing on it, is actually pretty advanced mold growth right there on the bottom of the OSB, or oriented. Now, both the areas that I had some of the worst damage are in the center of long spans, and in parts of these spans there's radiuses. So when you do a radius along a span, it's pretty much a good guess that you have a degree of sag along there, and that sag would allow for the water to go to the lowest point. and it seems to be that, you know, in the middle of these spans or around a radius, that's where we have the most damage. So it's a really good guess that water's just finding its low point, and it's finding that point to exit. In this video, I want to call attention to the detail that's up on the second story walk deck. That lighter line up there is a line of Cantera stone, and the Cantera stone is flush with the edge of stucco. So I'm going to look closely at this. You can see that they more than likely used the Cantera as a screed to apply the stucco. And the stucco does have a substrate as well as probably the Cantera. But note those white lines below that Cantera, and that would be areas where water is weeping out of the stucco. This is the Rio Verde area of northeast Phoenix, and those are a set of mountains to the north of us, and there's also some directly east. This is an area where two fronts converge when there's storm activity. It's cold out there and it's warmer in the valley. I myself have lived out here, and I know that the rains can come sideways because it's a violent clash of weather systems right here. So I'm deducing that the sideways rain is what has gotten so far onto that deck, and it is washing down that deck. Even though it does have an overhang, it's a very high overhang, so that allows the water to get pretty far up that deck and work its way into that Cantera, which is actually exactly like the surface I'm standing on. It's basically a honed, polished, concrete type product. It's very porous, and most definitely water will go through it. It has a very uneven surface, but also it's porous. Here I took the liberty of drawing a couple details. One, which I'm going to show you right now, is how I believe the Cantera deck on the second floor is built currently. And I want to go through where I think the pitfall is with that design. Okay, so what we have here is Cantera stone, mud bed, tar paper wire, subdeck, and then out at the edge of the house we have scratch coat and styrofoam. And basically I provided the arrows that show the direction of water and how I believe it's damaging the drywall underneath, but also some of the stucco. You remember earlier in the video I showed you how there was efflorescence out on this outside edge. That means the water is pushing out of the stucco this way. So the Cantera stone is porous. It's allowing water into the mud bed. Mud bed is acting as a sponge. It's wicking water to the scratch coat. This scratch coat could either be solid concrete of 1 inch, or it could be a combination of styrofoam and concrete. Styrofoam being the worst because it would allow the water to go right down the face of that styrofoam inside the wall and down into the damaged drywall below. But our current condition, either or, shows that we're getting water going this way. We're also getting water going this way out of the stucco coat. And you notice right there that finished stucco line. I noted that there was some stucco on the face of Cantera here, so they actually used the tile as a screed when they applied that color there. So they had an underlayment to some degree. They laid the stone, and then the stucco people actually used the tile as a screed to match up to it. This is how I believe it's currently constructed. So now I'm going to move you over to this drawing right now. And this drawing shows how I believe it should be constructed.
I'm Rob Farkas. I'm from Premier Construction Consulting, and this concludes this report.